In this module, we'll be discussing basic bioconductor infrastructure for genomics, microarray, and next-generation sequencing. And I'm going to start with the iRanges package. iRanges is a library for representing ranges of integers, which is useful in genomics because we have base pair ranges that we'd like to manipulate. So there's a very detailed vignette, which you can access as we showed before, using the browse vignettes function. And this contains a lot of detailed information about all the different classes and functions which are contained in the iRanges package. And this is really a very powerful package, and the code is written such that the simplest functions can be performed very fast. So it's worth taking a look there. I'm just going to show you a summary of the most important functions. iRanges have a start, an end, and a width. If you just specify two numbers, you specify the start and the end. So here we have an iRange which starts at 5, ends at 10, and is therefore 6 base pairs long. So here you can see that the first three arguments are start, end, and width. And if you specify the start is 5 and the width should be 6, you'll get the identical iRange. So the start function will return the start values, the end will give you the end, and the width will give you the width. You can also specify more than one range at a time. So if you give 3 starts and 3 ends, you get an iRanges object of length 3. So here you can see it has length 3. And if you again ask for the starts, you'll get the 3 different starts, 3, 5, and 17. But for the next code sections, I'm just going to use the single range, which starts at 5 and ends at 10. There are a number of intra-range methods for iRanges. And intra-range means that the operation will occur for each range that you have, and it doesn't depend on the other ranges that are contained in the iRanges object. So an example of this is to shift the iRange to the left by 2. So before we had an iRange that started at 5 and ended at 10, and applying the shift operation produces an iRange which starts at 3 and ends at 8. So in addition to the shift function, we also have a number of other functions, including narrow. Narrow says relative to the first to the start, you should instead start this range at the second base pair. So relative to 5, it should start at 6. And you can also say relative to 5, you should end on the 5th base pair, which means that it should end at 9. The flank function allows you to get flanking sequence here, 3 base pairs from the start. And you can also get 3 base pairs from the end by specifying start equals false. And you can say you want bidirectional flanking sequence from the start by specifying both equals true. And so now I'm going to just show you graphically the exact same functions I just showed you, using you just simply plotting using the plot function. So here I'm drawing base pairs, which so the number indicates the base pair, and I'm drawing the original range. So here the original range started at 5 and ended at 10. So you can see that the way I'm plotting it, it includes the beginning and the end base pair. So it's width 6. And just to make things more visually easy to see, I'll shade the shadow of this range in red. So shifting by -2 generates an iRange which starts at 3 and ends at 8 like we had before. And that just looks obviously like a shift to the left by 2. The narrow function, where we had it should start at the second base pair, that just means that this range should start at 6. So instead of starting at the first base pair, take the second base pair. And by specifying that the end should be 5, it's saying only go 5 base pairs from the start. So the flank function gave us 3 base pairs from the start to the left. and the flank function with start equals false gave us the flanking sequence downstream from the range. And by specifying both equals true, it gave us 3 base pairs to the left and to the right of the start. So that's just an easy way to visualize what's going on. There's even more intra-range methods, but I just want to show the most basic ones. The inter-range methods are those functions which depend on the other ranges in the object. So here let's create a iRanges object with 3 ranges, which starts at 3, 5, 17, ends at 10, 8, and 20. And if you ask for the range, this will give you the beginning of the iRanges to the end, including gaps in between. So this gives us the start of 3 and the end of 20. If we say reduce, it gives us those base pairs which are covered by the original ranges. So we do not get the gap, so the end at 10 and the beginning at 17. We can ask for the gaps, which gives us there's a gap from 10 to 17, and therefore the gap starts at 11 and ends at 16. Finally, we have the disjoin function, which gives a set of ranges which has the same coverage as the original iRanges object, but they're not overlapping in any way, and they also contain the union of all the endpoints of the original range.